Hi, welcome to a tutorial from Robojax. My name is Ahmed Shamshiri. In this video I'm going to show you first how to use a shunt resistor to measure current up to 500 or even higher using Arduino. In the next project, then we are going to measure the current using shunt resistor and display the current on the LCD. So some people who just need to display the current, they will use that project. In the next project, I'm going to show you how to measure any voltage with Arduino. I will show you all the calculation and derivation. Then we are going to combine the shunt resistor and display and create energy meter, which will show you the voltage, the current, power, energy, time, and all these features on the screen. Or if you want to use it without the screen, also I will provide you the code. Let's get started with this. There are many ways to measure current with Arduino, including different type of sensors made for this purpose, and I have a lot of videos related to those. I try to put the link below this video in the description, but this one we are using this shunt resistor that is sourced separately, and this has 75 millivolts rating, and we are going to use analog read of Arduino to read that voltage and do the calculation to display the current or get the current for other purpose that you want. This shunt resistor is sold for different current rating. For this shunt resistor there are two versions sold. This is a 100 ampere 75 millivolts, and as you can see this is 0.5% tolerance version, and this is a 50 ampere 75 millivolts, same thing, but this is smaller and it has plastic. So on the one hand this is better because you can install and attach it to something, and this is already insulated, but it has smaller connector. And the 100 ampere, because it's twice as much the current, then there is no such thing, but it has huge nuts and you have to have proper wiring for this. The current will pass through this. We put this shunt resistor in series with the load. The current will pass through this, and the voltage that appears on the resistor will be proportional to the amount of current. And here this is your battery and that is the load. We will be connecting two terminals to the load from the battery. How we use this is either we are using it, the positive goes to the load and comes here and passes through the shunt resistor to the negative terminal. So this is in series with the load, and we will be getting two terminals here. The ground is from the side where the battery is connected, and this side will be automatically positive because the positive goes here and comes here. So this point is positive with respect to this point, and we are going to connect it to Arduino to read it. Or you can connect it the other way and put the shunt resistor at that positive terminal and the negative on this side. In this case the positive comes on this side because the battery terminal is here, so this point is positive with respect to this point, and this is now negative, so we will be connecting this to Arduino to read it. With this shunt resistor on Arduino you can measure from 10 ampere up to 50. But if you get a 100 ampere version, also you can measure 100 ampere. But anything below 10 ampere, this is not a good choice. You will get a lot of error. You need to keep in mind analog read resolution. You can change it, but not for all the boards. For majority of the boards, it will be 10 bits. 10 bits means 2 to the power 10, which we get 1024 minus 1. So we have Arduino DUI 0 and MKR, the bit will be 12. So how we set it? We set using this. Inside the code we say analog read resolution like that, and here we put 10 or 12, and this will set our code. Then it will set our resolution properly. The other factor is analog reference. By default all analog are depending on the board. If the board is 3.3 volts, you will get 3.3 volts. If your board is 5 volts, you will get 5 volts. But you can change it inside. You can use this code inside the setup or anywhere that you want, and inside this, the opening and closing inside, you just enter one of these default, internal 1.1, internal 2.v, depending on the board. For Arduino Uno, Mega, Leonardo, etc., these are the values. For example, if you have Arduino Mega only, you can put internal 2v56. So to understand it better, the smaller the value, at 5 volts you will get lower resolution, 3.3 volts it gets better, 2.5 even better, and 1.1 is the best one. Now let me explain the wiring. I'm using electronic load as my load. The power is connected to my electronic load. I'll be connecting it like this. My load is here. I will put this in series between the negative terminal and the load. If you want, you can also do it this way. I'm doing it this way. This is the electronic load DL3031, and these are the two terminals that from the circuit will be connected in here, and we will see the voltage here and the current. As you saw, this has been connected to electronic load. This is coming from my negative of power supply, coming and passing from here, and this goes to the negative terminal of my electronic load. And from these 2 points, I've taken these 2 wires. The side that is connected to the negative terminal of power supply is my negative, and this side is automatically positive. That black wire is connected to this point, to ground, and the red from this side, this is a positive. This has been connected to analog 0. You have to have very thick cable to handle the current. You have to have very thick cable to handle the current. I'm using a very short cable here. After this point, I have very thick cable. You see 2 of them are connected here in parallel to handle this. And actually for my power supply, this is a cable that I'm using. And if you see and compare it with this, you know that this is a very thick cable. Now let me explain the code. I've defined here N pin for analog 0. You can change it to any other analog. This is a shunt current that is printed on your module, and here mine says 50 ampere 75 millivolts, 50 and then 75. Don't worry about 0.075, but just enter the milli, who's 75 millivolts. And then the correction factor from my experiment showed that if I put 2, I will get proper value. And you have to find a reference point, and based on that compare it and enter here a value. Below this, you should not change it, but here I'm providing it in case if you want to customize the code. For example, the iteration, we are measuring the average of 50 iteration or 50 measurement. So you can change it if you want to increase or reduce it. Voltage reference, I'm using 1.1 volts or 1100 millivolt internally from Arduino Uno. And if you're using different Arduino, make sure to visit this page. And here for Arduino Uno, Mega, Leonardo, and all these, you can use default, which will be 5 volts or 3.3 volts for the boards that are 3.3. You can use internal, I'm using internal, and you can use internal 1.1 if you have Mega, or internal 2.56 for Mega. And so these are different values that you see here. And that voltage, whatever, if you get 3.3, type here in terms of millivolts, 3300. And then the bit resolution, this is the bit resolution for the board. Arduino DUI and MKR, they are 12, otherwise the rest of the Arduinos are 10. This debug once. If you want to get the information on debugging, just print true, it will display it only once, but if you set it to false, it will continuously display the debugging values, which I'm going to demonstrate it. Inside the setup, we are initializing the serial monitor with 9600 baud. If I click and open the serial monitor, if I go to the right side and the lower corner, that is 9600. It must match, otherwise you will not be able to get it. Read the value, and this is just printing the text. And here analog reference internal, so this use 1.1 volt reference, and we are giving it 500 milliseconds for that. To get the current, we use print current. When you use this one, it will print the current. So it will print the current something like this if we use this one. But if we use debug, it will print huge values here. Let me show you. Serial monitor. Here it shows the pin 14, and it shows the shunt voltage, the shunt current, and then the voltage reference and the bit resolution, all your settings, so you can read it. And also it reads that this is a sense value at the pin, and this is a converted voltage, and this is based on the calculation, it's converted current. The first iteration is always incorrect, the first reading, so after that it goes stable and 25.27 millivolts, and it refers to 16, and then you see 19. So we are getting the average of all of this. This is the actual current that we are getting. So if you don't need the debug, comment this out, and this is the one that we are using to print the current on the screen. It just prints it continuously. But if I disconnect the wire, it will be just waiting like this. Now I have disconnected this input, and then this get current is a value that will give you the actual current. And here is how you use this. If you want to take some action or do something, use get current, and this is the actual value, and you can do a comparison if you want to check it to see if it is greater than 35.3, and you want to do something, do whatever you want in here between these two curly parentheses. So this is how you use it. You can get the full explanation of the code from my Arduino course at udemy.com, where I will explain everything in here. And now let me demonstrate it. At the moment, this is a current 50 ampere is passing through this, and we are reading here, it shows fluctuating between 49 something and 50 or 51. So this is how we are reading it right now, and this is when the current passes with 50 ampere here across this and 75 millivolts. You can see that you can calculate the amount of power here. I just changed it now to 40 ampere, and as you can see, we are reading this current here. And now let's set it to 30 ampere. It is now set to 30 ampere. And as you can see, this is the reading from this. And now let's change it to 20 ampere. Now the current is 20 ampere, and this is the reading of Arduino. Now let me change it to 10 ampere. Now the current is 10 ampere and we are reading this value. Remember, this is made for 50 ampere, so let's go to 5 amp. Now set to 5 ampere. So less than 5 ampere we cannot read, because the reason for that is the resolution of my device with Arduino. This is a 10-bit. The accuracy, because the Arduino Uno has a resolution of 10-bit or 1023 steps, so the minimum that this can measure in terms of millivolts is 5 millivolts, 4.88, and that is here. If we have 5 volts reference and then 1023, we get 4.88 millivolts. But if you set the reference to 1.1 volt with the same resolution, you get 1.075 millivolts, so which means the resolution is increased as the voltage reference is reduced. Instead of 5 volts, if you use 1.1 or 3 volts, 3.3 volts, so the resolution will increase. But if you're using Arduino DUI, this one, Arduino DUI, or if you have this MKR version, then the resolution will be increased to 12 bits, and 12 bits will be 2 to the power of 12. So with a reference of 1.1 with a 4095, you get 0.26 millivolts. So the resolution will increase. And resistor has 75 millivolts in total. 5 millivolts is a very important value here. And here now I'm connecting the 100 ampere shunt and changing the code to 100. Make sure this is 100. Upload the code, and here now 50 ampere is being drawn. Here my electronic load shows, and here we are measuring 50 ampere, 48.9 or 49.5. Change it to 60 ampere. Right now it is 60 ampere, and 60 ampere is being drawn here. As you can see, this is what we read now. Let's go to 40. Now it is set to 40 ampere. Let me change it to 30. As you can see, we are getting lower accuracy with 100 ampere version in this case. Let's go 20. So, and this is a reading for 20 ampere. 10. And that's the reading for 10 ampere. And because this is 100 ampere and 0.5 means 0.5 ampere error, constantly we will see it. And now if I go to 5 ampere, let's see, and we are getting all these incorrect value, because it doesn't make also sense that you use this 100 ampere to measure the 5. So you have to go with a lower resolution shunt resistor or a sensor that can measure from 0 to 5 or maybe 0 to 20 you get better resolution. But if you are looking at 100 ampere, you will see these challenges. And see here now, 50 is very close, so it works very well. Also make sure to get the code and watch the video of introduction to this LCD, and make sure that you're able to display a text on this and download the library. Once you use this separately and succeeded, and once you use this, the video introduction to this, and were able to display the current, then come to this. Otherwise, this and this one, you will get a lot of error and issues. For my LCD screen, we have 4 wires here. The wires for this LCD have been labeled as ground, will be connected to ground, VCC, SDA and SCL. Ground is connected using black wire to ground of Arduino. The second wire is VCC. This has been connected to 5 volts of Arduino. This gray is SDA. It has been connected to analog 5. And the last one is a purple, that is SCL. It has been connected to this pin, A5. You can also connect it to SDA and SCL at this point. And if you're using multiple devices, put a wire from here. You can, in parallel, you can connect up to 128 different devices. You have to have very thick cable to handle the current. You have to have very thick cable to handle the current. I'm using a very short cable here. After this point, I have very thick cable. You see 2 of them are connected here in parallel to handle this. And actually, for my power supply, this is a cable that I'm using. And if you see and compare it with this, you know that this is a very thick cable. Now let me explain the code. We have defined here the constant integer N pin. That is where we read the analog pin, the voltage from the shunt. Shunt current is the amount of shunt resistor that you have. Either you have to enter here 50 or 100 or whatever value you have. As you can see, this is 100, and I've entered 100. And if you have 50, just enter 50. That's the value. 75 millivolts is entered as 75. Do not worry about 0.075 in terms of millivolts. And the correction factor with this setting that I have, 2 is here because of the reference voltage. And this line you have to download and include it. I've explained that you need to watch that video separately. I'm not going to explain it. This is for Arduino library. This is for liquid crystal library. And in this line we enter the I2C address for the module. For this has an address. I have separate video explaining that, but for this you can run I2C scanner. You need to run I2C scanner. I will provide you this code. Just upload it, and once you upload it, open the serial monitor, and it will print the address for you. As you can see, it shows 0x mean hexadecimal and 26, and that's why I entered here 026x, and then 16 is number of character, 2 is number of lines. And if you're using 2004, it will work as well fine. Just put 20 and then put 4 here. Iteration is 30. Iteration we are measuring out of 30 measurement. If you want to increase the accuracy, perhaps go to 50, but it will be slower. Voltage reference, this is used internally by Arduino, 1.1 volts, and we have bumped it in terms of millivolts, so 1100, and bit resolution is 10 depending on your module. If you have Arduino DUI and MKR, it will be 12, so enter here 12. and then debug true is for the debug purpose. Inside the loop, this is just printing LCD display and put get current. This will send the current to this point on the LCD. Otherwise, we send LCD, we send 0, 0. That's why we are getting that 0, 0 when there is no current. And now here is the demonstration. As you can see, currently it is 50 ampere. Let me change the current to 40 ampere. The current is shown here 40, and now we are reading 40 ampere here with a little fluctuation or variation, which is normal for this type of shunt. Go 30 ampere. Now I just put it at 30, and we are reading about 30 ampere current here. And let's go for 20, and here the current is now 20 ampere, and we are reading 20 ampere on the LCD. Let's go to 10 ampere, and lower current we will get slowly a little error, but below 10 is not measurable. Now pay attention here, because if you want to measure less than 10 ampere, then there are very good sensors for that purpose. You can get it very tiny and you can measure it. I have separate video for those. The link is below the video in the description. Let's go 5 ampere. Still acceptable, but perhaps below this we will get error. Let's go to 2 ampere. And this is where we get error. So anything that you want to do, measure the current above 5 ampere and preferably 10 to 50 ampere, and there is a 100 ampere version of it. And here now I'm connecting the 100 ampere shunt and changing the code to 100. Make sure this is 100. Upload the code. And here is a demonstration with 100 ampere 75 millivolts shunt. I have to make sure that I have a surface here that is non-conductive connected. Right now the current is 0, as you can see. Let me go 20 ampere and turn it on. So with 100 ampere we are reading this value. Let's go 30 ampere. So still acceptable. Let's go 40 ampere. Right now 40 ampere is being drawn, electronic load, and let's go 50 ampere. Now electronic load is taking 50 ampere and this is our reading. Let's go 60 ampere. And right now this is the maximum that I can test with. 60 ampere current is being drawn, and this is now displaying it. And if you go even 100, perfectly it will display with. Just going directly jump into how to display this one and also reset it, and explanation for this. This has a lot of application in battery charging and solar charging and energy consumption, either charge or discharge of the battery, or many other sources that people are using where they monitor energy. This will be just basic display in here. In my upcoming videos, I will facilitate this to be displayed on OLED display, and also you should be able to monitor it over the web, over the Wi-Fi. Make sure to subscribe. The program that I have written requires this 4-line and 20 characters to display everything properly. So we will be able to display the current, the voltage, the power, which is the product of these two values, multiply it, you will get it here, and the amount of energy from the time that it has started. The time format is day, hour, on the screen. And this is based on LCD, the I2C module, so it has only 4 wires. Very simple. To measure the voltage, to calculate the energy, we need a voltage divider. Consists of 2 resistors. It consists of 2 resistors with 1% accuracy, so you can get very accurate result here. The program that I have written will work with any shunt resistor that you have, with any voltage and any current. There is no limit for it. So as you can see, this is a 75 millivolts, 50 ampere. This is a 75 millivolts, 100 ampere. So you can enter the value inside the code and get any value that you want. And as far as I know, these are the values available immediately. So these are 50 ampere, then we have this 100, 200, 300 and 500 ampere. Perhaps higher values are available, but these are sold on eBay and AliExpress, and perhaps on Amazon you can find and buy them. And here is how we prepare a voltage divider to measure the voltage, any voltage from outside. We need 2 resistors, and we will connect them in this way in series, and the majority of the voltage, the input arrives, will be dropped on R2, and a small portion will be on R1, where we will measure the voltage across R1 by connecting this point to analog input, analog, for example, analog 1, and this will be ground. So this is our input. We are measuring the voltage, and this goes to Arduino. And here is the formula how to calculate the VN, what voltage you can measure. I have separate video explaining and derivation of R1 and R2. Please watch that video. The link is below the video in the description. Here is a condition that R2 must be much greater than R1. In this case, it's around 40 times for 50 volts. And here we have V of Arduino. This is a reference voltage in our calculation that we use. If it is 5 volts, we will use 5 here, and in our case it will be 1.1 volt, so this will be 1.1. And now for R1 and R2, these are 2 physical resistors that we need, R2 and R1, and here is how we arrange them. We connect R1 and R2 together. From the middle point that the 2 are connected will be connected to analog input, in this case analog 1, and the other side of R1 will be called ground, which will be connected to Arduino, and it will be our negative or ground for the voltage input, and the input will go to the other side of R2. In this case, now this is the input, and this is the output from voltage divider, which goes to Arduino. Now I have these 2 resistors. I'm going to solder them now. First, twist the 2 resistors like this. I will apply some solder. This is this point between the 2 resistors. This is my R1. I have soldered this wire. Now I'm going to put the heat shrink to protect it. And here, this is the input side first. For this, I'm just putting this heat shrink to protect it. This is R2. To cover everything in one piece. So this is the input. I have put all those resistors inside this and then insulated it and prepared these wires. So this can be connected to my Arduino, and this side is connected to my input terminal. And also I put here an extra voltage voltmeter so it can display the voltage for me. This is the electronic load DL3031, and these are the two terminals that from the circuit will be connected in here, and we will see the voltage here and the current. For the wiring, you have to pay attention that you should have very thick wire, as you can see in here. And here is how the wiring is done. We will be connecting the positive to the load. The negative goes through this shunt resistor to the load. And if we want to just measure the current, we get one wire from this side and one wire from this side. The side that is connected to the negative will be our ground, and the other side will be our positive, which we will connect it to analog 0. And for energy meter, we need to prepare one wire from this, which goes to analog 0. So this portion is done. And then we have to prepare our resistors, R1 and R2. From the middle of these two is a pin that goes to analog 1. From the other side of R1, it goes to ground, which we have another wire. And from R2, we have another wire. So these two wires will go to our voltage source, which we will be connecting it to this side of shunt resistor, because this is ground. So we have one ground for analog 0 and analog 2. So it is common, and R2 is connected to the positive. What it means is that we have from the positive one wire and from the negative another wire. So we are getting the source voltage as well. I have put all those resistors inside this and then insulated it and prepared these wires. So this can be connected to my Arduino, and this side is connected to my input terminal. And also I put here an extra voltage voltmeter so it can display the voltage for me. Here is the wiring for the LCD. This side is ground. The ground is connected using the black wire to ground. The second pin is VCC or 5 volts. Using white wire, it has been connected to 5 volts. Then we have SDA. Using gray wire, it has been connected to analog 4. And SCL, the last one, is connected using purple wire to analog 5. This is I2C pins. You can also connect it to these SDA and SCL directly from here. And here for my shunt resistor, this side goes to the battery. I've connected the black wire. This will be connected to ground of Arduino in here. And this side, this will be connected. And this side is connected using this red wire to analog 0. We are reading the current from here. And from a voltage divider, I'm not connecting this ground because this ground is the same as the other one. I will just use only the output from, or one directly from my voltage divider here to pin analog 1. And let me now explain the code. First, you need to download the library that I've provided. First, you need to download the library. I will provide it as a zip file. Download it and save it. And then click on Sketch, include library, add .zip library, and then point it to where you have saved it. For example, if it was inside download and tutorial, and this was the zip, so select it and click open, and it will be done. After that, you can run this code, but I'm also including some examples within the code. So click on File, Examples, and scroll down until you reach Robojax, Shunt Current, and Energy Meter LCD. If you just want to read the current, just open the current, and for energy, click here, and then this will be the file. Shunt in pin, this is a pin that is coming from the shunt resistor. This pin from this side to analog 0, and then the shunt current, that's the value that is printed on your shunt, whatever value up to 500 or 1000 ampere if you can find, that's fine. And then the shunt value voltage, enter it in here. Correction value, this is because of the resolution of the device. We have to compensate with 3 to get proper value. Iteration is 50. We are measuring the value of 50 measurement, either voltage or current, and taking the average. And voltage reference, this is 1.1 volts or 1100, this 1100 milliamps. Because I'm using Arduino Uno, I can do this. For the other Arduino, I will provide you the link. And depending on the type of Arduino that you have, we use analog reference, and inside these opening and closing parentheses, which I'm going to show you next, we enter the value. If you put default here, this capital word default, it goes either with 5 volts, or if your Arduino is 3.3 volts, it goes with Arduino 3.3 volts. If you put internal, it will be 1.1 volts. That's what I'm doing. The lower the value, the higher the resolution, so it's better. Bit resolution for all Arduino is 10, but for Arduino Due and MKR it will be 12, so you will enter 10 or 12 accordingly. Debug once is a value that reads all the value for the settings and display it on the serial monitor, so you can find out the problem if you face some issue. Minimum current, this is supposed to be 10, so below 10 will be ignored. This is for future, not now, where we can change the format to display it in 5 days, 18 hours, 32 minutes and seconds. Currently it's shown like this, so don't worry about this. LCD character, this is the number of characters on your LCD. Right now this is 20 characters if you count them, and 4 row. So, but if you're using this one, it will be 16 characters and 2 row. So I'm using 4 character and 20 character 4 row, and this is I2C address 0.27. And to find out the address, I will provide you with I2C. If you go and click on example and Robojax Shunt Current, or maybe I'm going to change it to Robojax Energy Meter, and then click on I2C scanner, upload it. If wiring everything is correct, open the serial monitor, it will print the address 0x27. 0x means hexadecimal, 27 means the hex value of 27. So this value is taken from the I2C scanner. This is R1, R2, the two value for the voltage. I try to use my multimeter and measure it and enter it here, because the rating, for example, this is 1 kilo ohm, and when I measured it, it was 993, and that value, so you can get better result. And voltage in pin, this is analog 1, you can change it to any other, the same way for this one. If you want, you can change it. I've changed this variable, which was, and then internal calculation interval. So change the interval variable to display delay. Change this one, how often it displays here. If you put that every 2 seconds on the screen, you will see new information. And this line shows that Robojax Shunt Current LCD, this is for the library. And then from this library, we create this, from the class, we create something called shunt. And we pass these values, which I just explained at the top. All of them, they don't need any explanation, very simple. Inside the setup, this is just for serial monitor, and we have to have shunt begin, backlight, and shunt print. This will print on the LCD. That is this text in here. And this is analog reference internal. If you remove this, the voltage will be 5 volts automatically, but make sure also to enter here 5000 millivolts in terms of millivolts. If you're using 3.3 volts, enter here 3300. And analog read resolution, if you're using analog Arduino DUI, uncomment this by removing these / so this will set the resolution to 12, because if you just change 12, if you change this 10 to 12 and do not change the other one, it will not work. So change this to 12, and then inside the setup change this also, remove this, so this will be set to 12. And then inside the loop, these are the important functions. So shunt.show current, this will show the current, this will show the voltage, this will show the energy. So we need them, I put them separate because for some application you need to remove them. That's why I provided them all here. And here, that value that you set will come here and will change the display intervals. Show this debugging information, remove this comment or uncomment this line. Now I'm commenting it back the same way for serial monitor, and there is no delay and nothing in between. And here is a demonstration. Right now my electronic load shows 30 ampere, and here we are reading 30 ampere with some small fluctuations, and this is the input voltage that is connected to the load, and the multiplication of the voltage and current is here, the power, and the energy is here. And since I started it, it was like 1 minute and 55 seconds. Let's go 40 ampere. Now 40 ampere. And energy is being measured. Here I've changed the input voltage, and we are getting 3172 watts. So far 44 hours. I reset it, now it's 46 seconds. And here is a demonstration of resetting the value. This reset switch, if you need it and use it, you can use it, because otherwise you can use Arduino's reset switch either here or in here, depending on the board that you have. You can just press, the whole process will restart. But this is just resetting the energy and time. And if you have other processes running your Arduino, it will not be affected. So in order to reset it, we have to press this and hold it for 2 seconds. Energy and time reset, you will see it, and immediately the timing will start all over again. So this is very good option. And here is a demonstration when you uncomment this shunt serial, print serial, and upload it and open the serial monitor. It will continuously print it on the serial monitor. Let me stop this from this lower section, and here it shows the current, the power, the voltage, and the energy, and in terms of time it shows days, hours, minutes, and seconds. So if I scroll it down, you see this shows now the time continuously, but perhaps in real application you don't need that. You will need to just comment this out and display it on the screen, and at the moment also it displays here, so no worries. If you need to display the debug information, the full information, uncomment this line and then upload it, and this will go for 50 iteration or 50 measurement. So just wait and hold. So this shows the average of all these values, which is 24 ampere, and these are the important part that will help you a lot. So reading from pin analog 0 is pin 14, and for voltage shunt that's 25 millivolts. The current shunt that I've set is 100, and the voltage reference is 1100 millivolts. The bit resolution is 10, and it shows the correction value 3 unit. Debug 1 says also on, so all the settings that you have will be displayed, and this might be very useful. R1 993 and R2 46,140, and using these two also it will tell you the maximum voltage. With these two resistors we can measure up to 52 volts, 52.21. So do not change R1 and then play with this if you want to achieve, if you don't want to use a calculator and the formula that I provided. Just enter, for example, 100 kilo ohm or 500 kilo ohm, and let me show you. Let's make this 416 kilo ohm. Let me upload it. But with these changes that I made, we can measure up to 462 volts DC. Undo, let me undo it. Also keep in mind that once you run the debugging on the screen, all the reading will be stopped. So this will not read anything and it will stop, including the calculation and including the time, because debug 1 says just run the code once. And here if you set this to false, then it can run continuously. Today we are going to see how we can use this Allegro ACS712, which is at 5, 20 and 30 ampere AC and DC current sensor. In this tutorial we are going to learn how we can use this Allegro current sensor ACS770. They are available in a range of from 50 to 200 ampere. I'm going to test it with 50 ampere. This tutorial we are going to learn how to use the Winson WCS Hall effect current sensors to measure the current and display it on LCD1602 or LCD2004 with I2C module, which has only 4. In this tutorial I'm going to show you how we can measure any DC voltage with Arduino. As you can see now it is 12 volts and we are reading 12 volts in serial monitor. I'm going to explain how to calculate different resistors to measure any voltage, also demonstrate 12 volts, 24 volts, 36 volts and 50 volts.